Welcome to Lincoln House. I'm Armando Carbonell. I chair the Department of Planning and Urban Reform here at the Lincoln Institute-Loeb Fellowship Fellow. And as always, it's a pleasure to welcome you to another Lincoln lecture. Today with Scott Campbell, this year's Lincoln-Loeb Fellow. Scott has been very productive, spent a lot of time here at Lincoln House. We've been very happy to have him participate in our efforts in land conservation. And his topic is extremely timely for us as we have come to the conclusion in the land policy world that land policy actually means a lot when it comes to water resources and the way in which we can manage our water resources. And at a time when California is facing an amazing drought, thinking about how one might manage land, in particular in a state where 80% of the water is used for agriculture, and agriculture is not particularly part of the water strategy right at the moment, we think we might have a lot to offer. We have been working with partners at University of Montana, up in the Columbia River Basin, looking at tribal water rights issues. We've been working down in the Colorado River Delta, looking at restoration of that habitat. And more broadly, looking at the Colorado River Basin as an amazing overused resource. So it's quite timely that Scott comes here talking about surface tensions and the issue really of how do large landscapes, one of our top research areas and action themes here, relate to America's rivers. So Scott Campbell.
Great, thank you. Well, what a nice introduction. I was told when I was doing my orientation last year that the only downside to being a Loeb Fellow or a Lincoln Loeb Fellow is you can't flunk out and have to repeat a second year. So I'm very grateful for the year I've had, grateful to Lincoln Institute for hosting me. It's been a wonderful year of research and reflection. I'd also like to thank the Loeb Fellowship for sponsoring some research that I was able to do with students, some of whom are here today. We'll talk a little bit about the work we did together in the presentation. And you know, as Armando describes the Lincoln Institute's focus, emerging focus, evolving focus on water, that's very similar to the way I have entered this field. I was working in conservation for some time, probably heading up the Palmer Land Trust in Colorado for 5 years, working in large landscapes before I really started diving into the issues of water. Worked there 2 more years, starting to, I guess that's a bad pun, but dive into these issues. And then I've really wanted to spend my year out here doing a little bit more research because it's a complex field to be involved in. The students and I were able to take a trip to Colorado's Arkansas River Valley, and my title slide image has an illustration, a cartographic illustration done by Harold Fisk in the 1950s for the USGS, and it shows where the Arkansas River meets the Mississippi River. And what I love about this image is it shows all the different historic channels that these rivers have occupied, and we begin to get a sense of the changing nature and the very variable nature of these river systems, and that is actually indicative of a healthy river ecology. And as conservationists, we work to protect these ecologies, and that's one of the things that I want to talk about today, how we deal with problems of ecology in the conservation field. I also want to talk about problems of supply, which Armando has mentioned. So we're going to cover problems of supply, problems of ecology, some of the emerging frameworks that conservation practitioners are working within. So my work in Colorado took place on the Arkansas River, the Arkansas River watershed, the river itself and its tributaries. You can see right here, it is the second longest tributary of the Mississippi River system. The Arkansas, where I work, is in a very dry region. It is west of the 100th meridian, where we generally see less than 20 inches of rainfall a year. Its downstream areas are in a much wetter region, and as I wanted to better understand the consequences that some of our development of that river, as well as my own conservation efforts on that river were having downstream, I wanted to study both rivers in a very arid context and a wet context, and also rivers where there were large landscape conservation efforts taking place. So I had an opportunity to look this year at some work that is being done on the Colorado River, as well as the Connecticut River, our largest watershed here in New England, and also the most dammed watershed in North America. A couple pieces of note about these rivers. Of course, the Colorado, we think of the number of decades that have gone on where the river does not meet the sea at its delta. The Arkansas, we have one of the most expensive Army Corps of Engineers projects ever constructed on this river, and the Connecticut, as I mentioned, has the greatest number of dams of any watershed in North America. And when we think about supply problems, really we think of the West, we think of this area beyond the 100th meridian, and the water law framework that we work with out west is a little different than the framework out here. Out here, under the riparian doctrine, if you have property and a river is flowing through your property, you have a right to reasonably use water from that system. Out west, that is not the case. You may have a river flowing through your property. You may have no rights to the water in that river. Likewise, you may have a property that is not bordering a river, and you may have rights to supplies from that system. And the way you develop a water right is actually to develop the system and appropriate that water for beneficial use. Then you codify that right by getting a court decree, and in the prior appropriation system states that decree really sets your priority within a system of users, which that date becomes important because with limited sources, you want rights to be more senior and more reliable. The more junior rights in systems that do not have adequate supplies become less reliable. So a couple things to note as we move into this talk about supply and ecology, but particularly supply. These water rights, they are a private property interest out west. They can be bought, sold, traded, inherited, and that becomes a very important consideration to the work of conservationists. And in part, for those who are not familiar with the work of land trusts, like the one I ran, that is because we operate most often by obtaining real interests in property for the purpose of protecting property. That may be acquiring property outright and fee simple ownership. We may hold a deed restriction on that property, or we may hold a deed of conservation easement on that property, restricting the development potential of the property in order to protect the conservation values. And this is where your deeds can begin to designate how water on that property can be used, whether it can be severed from the land, whether it's strictly for agriculture, whether it can benefit in-stream flows. And for those of us who are working on large landscape contexts, we are generally looking at protecting a couple of things. A relatively natural habitat of fish, wildlife, plants, or a similar ecosystem, and also the preservation of open space, in particular land in our food growing regions, farmland, ranch land. And the picture that you see here is actually the students and I during our trip out to Colorado on a large conservation project. This is the BX Ranch, which is a 25,000 acre ranch in Colorado's Arkansas River Valley. It is a project looking to protect a native shortgrass prairie ecosystem. It does not have a lot of water on the property itself, but it gives you a real idea. This is before things green up. This is mid-March, but it gives you an idea nonetheless of just how dry the landscape is. And out here, for most agricultural production, when you have an area like this that gets about 10 inches of rainfall a year, supplemental irrigation is required. And so this is an area that the BX Ranch is actually bordered by a number of irrigated farms. And we are also working to do some farmland protection projects, and in particular protecting the water resources that keeps those farms active and working. So let's move into some of the problems of supply that we see on this system. And I'm going to talk about the problems of supply in the dry region, and then discuss the major problem that we're seeing on the Arkansas. And then we're going to take a journey downstream, following this freshwater journey to essentially the point it ends in the Mississippi Delta, and we're going to explore a problem, an ecological problem that we have down there. Then we'll retrace our steps and look at, again, some of the conservation frameworks. Now, I thought I would share with you some articles that my Democratic-leaning mother and my Republican-leaning stepfather have sent me over the course of the year, highlighting just where our supply problems lie. If you read this article, this op-ed piece in the New York Times, you will see that this much can safely be said: agriculture consumes more than its fair share of water. If you read the next article in the High Country News, you see the finger put on the growing cities along the west, in particular along Colorado's Front Range. Farmers have been using the same amount of water for many, many years. It's the cities where the problem lies. Or if you read the Wall Street Journal, Congressman Tom McClintock is very discouraged by the fact that we have these huge pulse flows going into the Pacific. The problem is really lying with the environmentalists when the state desperately needs water for both municipal and agricultural consumption. Now, the pulse flows on the Colorado are occurring in a river that we typically think of, as Armando has mentioned, where we have demand starting to exceed supply. And in fact, this line right here shows the demand on the system exceeding supply for the first time in 2002. This does not mean it's necessarily hasn't been over appropriated before that. This is somewhat of a coin of phrase up here. But I'll point out here that the interstate compact involving the 7 states that the Colorado flows to was, at least the first part of it, was signed when flows were unusually high. And it allocated the water between different parts of the basin according to these high flows. Well, we know now that really the flows are much lower than projected. We also know that they are probably going to continue to decrease the supply in the advent of climate change, and our demand is increasing. But I would like to talk with you today about the problems we are having on the Arkansas River, which I believe is really the crucible for how we're going to handle these supply issues that are occurring across the American West. This is a river that has been over-appropriated and facing some significant supply hurdles for a very long time. The Arkansas River in the state of Colorado, its headwaters state, I may not have mentioned this yet, but it flows through Colorado into Kansas, then starts going into the wetter regions of Oklahoma, and then finally into Arkansas, where it meets the Mississippi. But Colorado is its headwaters state. It has its headwaters up high on the Continental Divide, and it flows through the eastern plains. It's the largest river basin in the state. It holds the least amount of water. 80% of the water in Colorado is on the western slope, the land that falls west of the Continental Divide and flows to the Pacific. 20% is on the eastern slope here. That is where about 87% of Colorado's population lives, and that's a population a little bit over 5 million people right now. It is growing at nearly twice the national average growth rate, so it's a population that is projected to reach approximately 10 million by 2050. To give you a view of the ground cover in this NASA image, you can see that, again, half the state is mountainous, half is in plains. You can see some of the major cities. The large growth area that is going to occur and the most populous area currently is along the Front Range here. Here's the course of the Arkansas River where it moves through the plains. This is the Santa Fe Trail, where it was one point where settler culture arrived and then spread across the American West. And some of our more senior water rights and our more historic agricultural settlements are along this river valley here. And this is actually the upper Arkansas watershed, but we in Colorado call this the lower Arkansas River Valley, this being the upper. Depends what state you're in, what perspective you hold. And I'd like to point out a couple of things as we move into the rest of the talk. You can see in this satellite image the land conversion taking place where we have these growing cities. You can also see a conversion over here, this sort of pocketed area, where native prairie has been tilled for crop production. Some of this is dryland farming, but a lot of it is irrigated through groundwater, either non-renewable supplies or groundwater where the output is really exceeding the recharge. So these are non-renewable water resources in a lot of these places, providing irrigation. Here in the lower Arkansas Valley, we have one of the largest intact pieces of native prairie left in the country, which is one of the reasons why we're so active there as conservationists. And we have really some of the state's more productive agricultural areas and a supply that is essentially renewable in the Arkansas River. Here in this slide, you can see when the problems of supply, how they fit into the relatively recent history of Colorado. 1862 is the Homestead Act. 1874, we saw the last water rights, major surface or storage water rights decree in priority 100% of the time established. 1876 is statehood. By 1887, water rights decrees that date back to appropriation dates of 1887 are in priority today less than 50% of the time. So if you hold one of these water rights, half the time you are not using that water. And you can see that occurring in the graph right here. And then, of course, as we look down to more recent appropriations, they are very junior and able to be used only a very small period of the time. And this created a lot of contention between the states. We have one of the longest ongoing Supreme Court litigations over water between states, starting with Kansas versus Colorado in 1902. And the most recent opinion was recently issued in 2009, with Kansas claiming, as it had in many years prior, that not enough water was crossing the state line from Colorado into Kansas under the interstate compact that the two states have. So this is the big trend that is occurring down in the valley. This is a map of one of the planning areas where we work. What do you do if you are a growing city operating in an area where you have over-appropriated, you're working in a watershed that's over-appropriated, but your demand is growing? Well, there are relatively few ways that you can acquire new supplies. And one of them, though, in this prior appropriation system, is that you can acquire these supplies from an existing user. You can buy a farm or a ranch that has water. You can fallow that farm or ranch and divert the water, convert it to a different type of use in the water courts, from agricultural to municipal, and you can divert that water for municipal use. Well, you can imagine that one farm conversion has a certain amount of effect on the local fabric and the local economy. But once more farms start to get bought up, that's less produce into the packing shed. You may see a packing shed close down, an equipment supplier that is supplying, let's say, tractors to farmers and exists on Main Street. All of a sudden, his economic base is being eroded. And what we've seen in southeastern Colorado is a real pattern of decline, starting with this buy and dry trend. The map here shows soils along the valley that are prime and irrigated in green, and the brown is areas that used to be prime soils, optimal growing characteristics, and irrigated, but have been permanently fallowed through this buy and dry. And an area that had historically 376,000 acres has seen over 100,000 acres dried up, and between 20,000 more acres to 70,000 more acres potentially in the pipeline. And if you're a farmer down there, you can imagine what the effect is. Why would you invest in more equipment if you don't know if there's going to be a future for you and your family? Why would you purchase the adjacent parcel of land that might be available to enable your children to be part of a growing operation if you don't know that there's a future that's going to be there? So this has had tremendous impacts in southeastern Colorado. Again, just a graph here showing the amount of land in communities in that map that was historically irrigated. This is the 100% line. Purple is what was dried up. Blue is what is still irrigated today. And when we look at those counties where most of the dry up has occurred, we see that although this has been a poor area historically, poverty rates following the dry up are now some of the highest in the country, exceeding 35% in these counties. One of the things that I wanted to figure out as we started working on this issue as a conservation organization looking to protect water through conservation easements by tying it to the land is, what are the impacts not only of the development of this water resource for agriculture, but our impacts in tying that to the land so that it can always be used in agriculture. What are the impacts of that downstream? Because we know that anytime we have an intervention in a river system like this, unlike working in the terrestrial plane, there are much more immediate and dramatic impacts as we go downstream. And this slide shows the different ecological regions that the Arkansas River flows through, from the montane areas through different prairie ecosystems to the central forests and grasslands and Ozark Mountains as we move through Oklahoma and into Arkansas, where we have the Mississippi lowland forests. Well, one of the things that I expected to see when I got to Lincoln and started doing research was I thought maybe we're going to see here what we've seen on the Colorado, which is that we had a lot of water, and the water has dried up as it was appropriated in the 1800s. But actually what I learned was it was a little bit different, and this I think speaks to how the nature of every river system is a little bit different. As the early irrigators began building hundreds of miles of canals and began bringing water out of the system and into the soils, it was charging those soils, and there were return flows and flows coming through the soils themselves that continued to charge the river into late, middle and late summer. And the Arkansas River in the mid-1800s was a river that often did go dry in late summer before it hit the Kansas line. Its tributaries would most frequently go dry. There's not a lot of water in the tributaries. And so as these farmers' interventions started to happen, we began to see the river already change. It had a more stable supply in late summer, but it also started to create channels. The river, where it crosses into Kansas, the riverbed actually narrowed. Its width was cut in half. It started to become a little more entrenched, I guess you would say. And that's just one way that it began to evolve. Another intervention that I found very interesting was early farmers introduced the honeybee into the area because it emerged earlier as a pollinator than the other native pollinators like this native sweat bee. And that enabled pollination of crops in this warm region of the state to occur earlier and water to be appropriated earlier in the season. So a lot of very small interventions taking place on land can have pretty significant impacts on the river system as a whole. Now, the Arkansas is a major sediment carrier to the Mississippi River system. The Arkansas, the Missouri, the Ohio, the upper Mississippi above the Arkansas, these all carry major amounts of sediment. And these sedimentation regimes are part of this variable and ever-evolving land building process that we discussed early on. And it's one of the things that I'd like to talk about now as we look at some of these problems of ecology and follow the river through those 7 ecological zones to where the freshwater journey ends into the sea. You can see in this analysis done by some of the students that I had the opportunity to work with that it is a highly engineered river, 486 dams across the river and its tributaries, the majority being built in the 70s and 80s, including, as I had mentioned, one of the most expensive Army Corps of Engineer projects, a 500-mile lock and dam system between the mouth and moving up into the Tulsa area. There is a very significant problem that starts to happen as we change not only the flows in rivers, but the sedimentation regimes that many of you are probably familiar with. This is about as well known of a scenario that we've seen here in the Mississippi Delta, as is the fact that the Colorado River no longer reaches the delta. This is an animation from Jeff Carney at the LSU Coastal Sustainability Studio. This shows how these sedimentation processes from the end of the Ice Age about 7,000 years ago forward actually helped to form the Mississippi Delta that we know today. This variability, variable characteristic that these rivers have, bringing large sediments and larger pieces of sediments, which take oftentimes tens if not hundreds of years, down from upper systems. Moving down, forming land in the Mississippi Delta, you can start to see Lake Pontchartrain form in this area here. The delta is starting to take a shape more like that we know today, moving into the present millennium and to the point where we're going to see the city of New Orleans established right here, and then the evolution of the boot down at the Mississippi Delta here. Really neat animation. I didn't feel like I could be at the Graduate School of Design without coming here and showing some tricked out animation. But here we have a NOAA image of the delta in the 1930s. Since 1850, the amount of sediment in the lower Mississippi River has decreased by more than 70% due to dam control in the upper reaches. And we also know that that sediment is not reaching other lands because of the levees to create this land building process. So if you watch this slide carefully, you can see what has happened is that the land building process has reversed and the land is disappearing. And since the 30s, there has been a disappearance of about 2,000 square miles of land that are now underwater. And if we think about the effect of this, that land was a big natural storm surge barrier. And with that land gone, of course, severe weather incidents like Hurricane Katrina become much, much more severe and devastating. In fact, the floods of 1927, which really precipitated a lot of this construction, this flood control on the Mississippi River, there were less lives lost in that major flood incident than during Hurricane Katrina. 500 historically, 1,800 following Katrina, which I think, if I've got it right, was back in 2005. This is from Louisiana's new coastal master plan showing what will happen to the existing land by 2050 in a do-nothing scenario. Red is what will continue to be lost. The green here is where we see flows actually establishing new land, indicating that if we can restart some of these processes, there may be hope. Now, it's interesting to me the way that our thinking has evolved from the time that the flood control acts of the 20s and 30s were passed until now. I just love this quote that comes out of the Mississippi Valley Committee report following the Flood Control Act of 32, which says the ideal river, which would have a uniform flow, does not exist in nature. You compare that to our thinking today, authors and river scientists like Angela Arthington, who says to protect freshwater biodiversity and maintain the ecosystem services of rivers, like land building, natural flow variability or some semblance of it must be maintained. And Kim Lutz, who's the director of the Nature Conservancy's Connecticut River program, shared with us some hydrographs that I'd like to share with you because they're just indicative of the difference between a healthy natural flow pattern and a dam-altered pattern. And she said, it's much like looking at an EKG. You can see the pulse of the river and having these variable flows, these high points and these low points, and this is what you want to see in a system. And a dam-altered flow pattern can oftentimes look more like a flat line. And in sharing about her work with the students and I on the Connecticut River, she highlighted how some of the species in the Connecticut River Basin, some of the trees like the silver maple and the eastern cottonwood, their seed dispersal and germination is actually happening at these high flows. During the low flows, that's the growing season. Likewise with the American shad, adults are moving up river during the high flows, spawning after those flows decline, and the juveniles are migrating downstream in the lower flows. So there's a whole network that this seems to make common sense, but we know has evolved with the system working the way it has worked for a millennia. Now into part 3, where we look at some emerging frameworks. Of course, this is our winter landlines covers showing the Colorado River meeting the sea for the first time in a long time. This is a great conservation accomplishment, and it demonstrates what can take place when you have conservation organizations and a host of partnership organizations working to focus on an entire hydrologic basin. A lot of times in land trusts we have a territory and we focus on that territory, but that doesn't necessarily work when we start focusing on these larger freshwater systems that move through these lands that we are protecting, and an intervention in one area may not benefit the system downstream. The pulse flow in Colorado was created in part through a binational agreement between Mexico and Colorado. And in some sense, I guess you could call it that there was a bit of water banking involved in this project. Now, technically speaking, water banks, they're market-based mechanisms that where you have storage permitting, enable water users to forego use, bank that water in storage, and use it later to transfer the right to someone else to use. We see this in Colorado. We have a voluntary flow management program on the upper Arkansas where we have storage upstream, we have storage downstream, and despite the river being completely over appropriated, the state, through this voluntary effort, is able to manage the flows flowing through a certain section of the river in ways that benefit fish and even benefit the rafting industry. The Arkansas headwaters is one of the most rafted rivers in the United States. And so there is management itself that can take place, and also when conservation organizations can start to acquire some water rights, even on a temporary basis to influence these flows, lease rights through water banks, this can also be helpful. Another example of what can happen in terms of water banking and flow regime planning, besides what's happened on the Colorado, is what we see when we return to Mississippi Delta. And here is an animation of a planned sediment diversion project that has been approved by Congress, the Myrtle Grove Sediment Diversion, which is south of the city of New Orleans. You can see the levee-locked waters here, the diversion pipeline in this close-up coming here, pumping water into the Delta region, and the rebuilding happening of sediments or land, the distribution of sediments and the rebuilding of land happening on a seasonal basis. If we move ahead in the illustration, it's just neat to see that take place. Getting back to the actual infrastructure that's going to be built, what I like about this diversion animation that shows the scale of water coming out of the banks is how they demonstrate the sedimentation process here. Again, this has been done by Jeff Carney again, but look at your hydrograph down here. Correlating the flows off this diversion with the high flows in the river that are carrying the greatest amount of sediments, and then you see those sediments depositing over here. I hope those of you who are in back can see the hydrograph. It's somewhat faint. So I think these are great examples of where we have large-scale interventions taking place. Now, flowing back upstream, as we look at some of the Rocky Mountain states where we have the supply problems, the right to appropriate water in these prior appropriation states has been historically pretty unhindered. We look at the Colorado Constitution, and it says the right to divert the unappropriated waters of any natural stream to beneficial uses shall never be denied. But then we start to see this taking place, and this is not in Colorado. This is a picture from the Clark Fork Coalition of Racetrack Creek, a tributary to the Clark Fork, showing what has happened to the river as it's been over-appropriated. And a lot of states began to address these issues in a rather in recent history. In Colorado, legislation was passed in the 1970s that recognized the need to correlate the activities of mankind with some reasonable preservation of the natural environment. Now, this didn't necessarily give the river rights, but it gave the state rights and conservation organizations a vehicle to begin to work with a new kind of right that was created. It's not an agricultural right, it's not a municipal right, it's a right for water to be flowing actually in the stream. And it's this kind of right that we see here reestablishing the flows in one of the Clark Fork tributaries because of conservation groups working to protect land with a rancher, creating greater efficiencies on that land so the rancher can use less irrigation, and then taking some of the surpluses that are created to that and establishing those surpluses as an in-stream flow right. Now, if we think about how we can appropriate water rights like that to serve multiple purposes, we'll run back now to southeastern Colorado. This is a photo that shows the Arkansas River weaving its way through the irrigated lands that have not succumbed to the by and dry. You can see how dry the rangeland is here. You can see how lush the fields are here that are provided or supplied with supplemental irrigation. And this is what it looks like when the by and dry, where the by and dry has started to occur, the difference between the irrigated pastures and the non-irrigated pastures. This is a photo that was taken when Jennifer Pitt with the Environmental Defense Fund wanted to see what could some of the outcomes be on the Colorado River as we start to deal with these supply issues. Where did she go for this flyover? To the lower Arkansas Valley to see what was taking place down there. Now, these lands are permanently fallowed, and one of the questions that is often asked is, well, do they have to be permanently fallowed? Can't we temporarily fallow these lands and use some of the waters from farms to supply a city? Well, there's a number of problems with that. I mean, first of all, if you look at one farm, if they were to rotationally fallow fields and allow them to rest, they may be rotationally fallowing once every 5 years, 2 or 3 times every 10 years. And that doesn't provide a city with a very reliable supply. If multiple farms start doing that, the city is all of a sudden starting to negotiate in very complex ways with different water users for those supplies. The other problem that the cities have in a very competitive water market is that they want to guarantee, why would you lease water? And leasing has transpired in a limited basis down in the valley, but why would you lease water when what you really want is control? And if somebody else were to purchase that farm, you may lose your supply. So control is what folks are looking for. Well, one of the ideas that has evolved down in this area that came from a local water conservancy district that was established in 2002 is this idea of the super ditch. And the super ditch is not a ditch, it is a corporation, and it is a lease negotiating agent that is working with farmers and cities to work with what will hopefully be this great combination of protected lands, farms that have conservation easements on them, where those easements allow this temporary fallowing and pooling of supplies to this agent that can negotiate with the cities over price in the market and over supply, and pool those resources, and also provide a lot of the due diligence around the temporary conversion of water rights that will be needed for the cities to make it a little bit more how would we say, appetizing for cities. So, we know we have growing populations in this area that we need to provide supplies to. We know that we have a growing population globally and need to increase our food supplies. This, I think, is one of the more innovative ways that we're starting to manage this issue. And after 7 years of planning, the first project is actually taking place right now this summer, which is an exciting thing to see, this pilot project taking place. I think it's a great model, too, for how we might start thinking about in-stream flows and water leasing as well as sales to help create better in-stream flows as well. So in closing, looking at the same area that we've been working, I'm sorry, the slide is a little bit overexposed and bled out on this projector, but here's southeastern Colorado with the Arkansas River flowing through it. Our land parcels in green are some of the lands that have been protected by conservation organizations like mine. These are huge parcels down here. The 25,000 acre ranch that's in progress right now is just about yay big. So probably you're looking at about 500,000 acres conserved in this region. But you can see what's been protected along the Arkansas River's course. Really we're just getting started there. We're definitely behind in looking at these river systems where we are working on the terrestrial plane. So a couple of things in terms of broad approaches I'd like to mention, and then we'll close and we can perhaps get into some of the more technical issues during the Q&A. I think one thing that's become really critical for the Land Trust is to engage in these water networks, these complex networks. And I love the quote here by Larry Susskind with MIT. He says, we really continue to treat this problem of water allocation as a technical problem. And it's not a technical problem, it's a societal problem. And we need venues where we can have democratic processes for people to get involved in these, what can be rather complex solutions, but need to be democratically informed solutions. When I talk to anybody about buy and dry in Colorado Springs, and Colorado Springs is one of the cities that has been a major purchaser of farms and permanently fallowing them in the lower Arkansas Valley, nobody in that city knows that this is taking place. And most people in that city, when they do find out, they don't want to be that kind of neighbor. They want to have a different way to look at engaging these kind of issues. So one of the things that's happening in the state that I think is real exciting is in 2005 we passed legislation creating the Water for the 21st Century Act, and it created these interbasin roundtables, a basin roundtable, an interbasin compact committee, and it's really a forum to address these rather difficult issues. So I think for land trusts, starting to engage in that work, partnering with water trusts, another emerging kind of trust, is a great way to do it. I think that's real important. And then we can begin to consider the technical needs because land trusts, and especially with the use of conservation easements, we can prohibit a change of the water right from irrigation or other existing applications. We can explicitly require a change. We can protect an agricultural piece of land and retire that water right and require that it be dedicated to in-stream flows to improve the ecologies, or we can allow a change of right within defined parameters, perhaps giving the landowner options on whether or not he or she would like to use that right to benefit municipal sharing or in-stream flow programs. So with those things in mind, I think that's how we as conservation professionals can begin to work on protecting our priorities within the system. Thus endeth the lecture. Thank you very much for your time and attention.